So, good afternoon, sir. I created two computer networks with the first network named Engine Office LAN with a default gateway of 172.16.1.1 with one laptop, two desktop computers, and one server. And the next computer network is the External Communication Services LAN with a default gateway of 172.16.2.1 with a network of one laptop consisting two desktop computers and one server. Okay, so in the task 3 I created the Engine Office LAN. It consists of one laptop, two desktop computers, and one server. In the one laptop, the IP address is 192.168.1.101, and the next is the desktop computer 1, which has an IP address of 192.168.1.102, and the desktop computer 2 has an IP address of 192.168.1.103, and the server has an IP address of 192.168.1.104. So, the topology I chose is the star topology. Star topology is a type of network topology where all devices in a network are connected to a central hub or switch. Each device has its own connection to the central hub, and communication between devices occurs through this central point. This topology is commonly used in Ethernet networks. Okay, key networking devices in a star topology include: number 1, central hub or switch. Its function is it is the core of the star topology. It serves as a central point of connection for all devices in the network. All communication between devices goes through this central hub. Number 2. Nodes, devices, computers, printers, etc. Its functions is that nodes are the end user devices such as computers, printers, or other peripherals. Each node has its own dedicated connection to the central hub, and communication with other devices in the network is facilitated through the hub. How star topology works. Number 1. Central communication. The central hub or switch acts as a mediator for all communication within the network. Next, when one device wants to communicate with another, the data travels through the central hub. Number 2. Isolation and fault tolerance. If one connection or device fails, it does not affect the rest of the network. Other devices continue to operate normally. It's easy to identify and isolate faults because the failure is localized to the affected connection or device. Number 3. Scalability. It's relatively easy to add or remove devices in a star topology. New devices can be added by connecting them to the central hub, and the network remains unaffected. Number 4. Performance. Performance is generally good because each device has its own dedicated connection to the central hub, avoiding contention for network resources. The central hub can be a switch, allowing for full duplex communication, meaning data can be sent and received simultaneously. Number 5. Maintenance. Maintenance is simplified compared to other topologies because troubleshooting and identifying faults are easier. Upgrades or changes to the network can be made without affecting the entire system. Advantages of star topology. Number 1. It's easy to install and manage. Number 2. Fault isolation makes troubleshooting easier. Number 3. Scalable. Additional devices can be added without affecting the network. Number 4. High performance due to dedicated links between devices and the central hub. Disadvantages of star topology. Number 1. Dependency on central hub. If the central hub fails, the entire network may be affected. The central hub becomes a single point of failure. Number 2. Cost. The cost while the cost of cabling in the central hub can be higher compared to other topologies, especially for large networks. Number 3. Limited length of cable. The length of the cable between the central hub and the devices is limited. In summary, a star topology is a robust and commonly used network configuration that offers easy management, fault isolation, and good performance. However, it does have some limitations, primarily the dependence on the central hub and associated cost.